Are you ready to start? Or
Yeah, whenever you're ready.
okay. Hello everybody. Welcome to our 2021 open house. We're planning on showing you guys what we've done so far and what we're planning to do. And I'd say enjoy it and stuff. And here is Dakota just giving some context for those who don't know us that well yet.
All right, so my mic is working, right?
Yeah. Yep.
All right, cool. So FIRST is an organization that encourages involvement in STEM. Every September they release a challenge, and we have until February or March to design a robot to complete the challenge. This year's task is called Freight Frenzy. We need to be able to move cubes, balls, and possibly rubber ducks into a multi-tiered shipping hub, as well as be able to detect different colored lines on the field and detect specific objects on the field. Us, the Manchester Machine Makers, were established in 2019 by Mike Cole, who is present. We are under the umbrella of 4-H. This year, 2022, will be our third year competing. We have grown from a team of 5 to a team of 9 with students from all over Bennington County area.
Since we are an FTC team, an important part of what we do is outreach. And in this past year, we have received a donation from the Orvis Charitable Foundation for $500 and a donation and internship opportunity for team members from the Engineered Printing Solutions in East Dorset VT, EPS, marking the beginning of a partnership of support and mentoring. We've also been awarded a grant for the Vermont Academy of Science and Engineering, VASE, which the team will use to build programming boards, which allow the programmers on our team to easily test and develop code. In general, these grants and donations will be most notably used to buy parts, as it is one of our biggest expenses, but will also be used when needed for registration fees. Your donations and support are greatly valued by the team. Although we don't list them all here, we are grateful for the donations that we have received from friends and family. Currently, we are participating in an ongoing matching grant of up to $500. Now you can donate through PayPal using the QR code at the top of this slide.
This year, we launched a new website with a new design using WordPress.com, and we also launched a blog on there, a new blog. We were previously using GitHub Pages, but that was not very user-friendly for new members and generally anybody who wasn't a programmer. And it also ended up with us spending close to more time building the website than building the robot. And so we switched to WordPress so that we could spend more time building the robot and focus less on the website, and so that everybody could write on the website instead of just some people.
We have a great new workshop that was donated to us by the Carocchio family from TPW Real Estate, and this is our first season using it. We're located in unit number 402, which is near the Manchester Gym. And we also share the space with some of the younger FLL teams, which is a Lego League team that builds with Legos instead of aluminum and motors.
This season, the team has begun sending out updates to its supporters to keep them informed. These newsletters are posted on our website and sent out monthly. Look out for our December update, which is coming this month.
So this season, we have been focusing on having hard deadlines to meet when it comes to building our hardware and just generally our robot. So far, we have a working drive base, which we built and finished by November 23rd. So it was originally designed as seen in the left-hand picture, but we then had to change it a little bit. We reoriented the front motors and we removed 2 of the interior beams just to allow for just because of some size constraints, and there was some issues with the tolerances and not being able to fit in the intake and the delivery mechanism. So on the picture on the right is our current drive base, which is working. And there are some videos on this next slide. So this first one is just us testing the wheels, making sure that it could turn on, that it could work. Then the one on the right is us doing our first drive on November 23rd, which we were all very happy about.
All right, intake. So basically for the intake, the main goal is to bring in only one game element at a time into the robot, and that's also called like a piece of freight, like you saw earlier, like cubes and wiffle balls and stuff. And so our idea is to have rows of compliant paddles made from trimmed wheels. So we're going to trim the outside off of these wheels off, and we're going to guide the elements up into the robot and then into the delivery chute, which you'll hear more about later. And so, yeah, we'll have these flexible rows of wheels, which will be able to accommodate freight of different sizes. That was one of the challenges because they're not all the same size. And there's going to be a motor in one of the vertical channels that's going to drive a sprocket, which will be chained to the other axles and make them spin too. And also, in addition to this, we had to design some plexiglass for the robot to kind of guide the freight up a little bit because it's not just straight, it's got to go up into the delivery. And we're almost done with our first prototype. Well, we are done, but we are going to need to get slightly different parts because right now the bearings that we're using, it made the whole thing kind of like loose. So we haven't gotten like a working prototype of it yet, but we're really close once we get these parts. So yeah.
Okay, so some of the challenges we faced are all the freight have different sizes. So the ball is the largest, the duck is the smallest, and the cubes are the medium size. We can't have the wheels to set in to bring only one size. So because the ball, because then the wheels would not reach the duck. The intake has to get close enough to the delivery system so that we can get the freight into the delivery, but it cannot block its functionality. Currently the channels support the wheels. Currently the channels that's supporting the wheels are a bit too big and would interfere with the delivery. There are like two holes too big. The delivery system starts a bit off the ground, so we have to create a plexiglass ramp to bring the freight up to reach the delivery. The rules of the challenge specify that we're not allowed to handle more than one piece of freight at a time. And on the playing field, all the freight is together in a space, so it will be hard to only spin in one piece into the system.
All right, so for the intake, we use different components like the wheels, which we use to, bring the freight up. We use the frame to like keep it all together. The motor spins the wheels, as Amos said. And we use the plexiglass to create a ramp that will bring it into the delivery system.
So the intake team was mentioning the delivery system a lot, and this has to lift the field elements up by about 24 inches because that's where the highest tier is in the capping, which we need to be able to do. So we have some linear slides, which are mounted together with these 3D printed inserts you can see in the rightmost image. And those are driven by a pulley system. Then in between the slides, there's going to be a chute, which holds the field elements. And that chute can tilt up and down to dump out the field elements using servos that it's mounted to.
And so here's a video that someone took the other day of our current set of slides.
And right now we have 3 stages of extension there, which is 690 millimeters or about 27 inches. And all of the modeling for the delivery has been done in CAD so far. So you can see here, this is what it's going to look like with the chute in between the two slides and then a door to keep the elements from falling out. The linear slide is on the left. We had to get a custom piece manufactured by EPS, and that was made out of aluminum so that the slides could be at an angle. And that piece is at the top. And then the door looks kind of like a field goal in football, which is done so that it can go around the pole of the shipping element for capping. And then in the bottom right, that's the plexiglass that Charlotte's currently cutting for the chute, because unlike the center image, we're going to make that out of plexi sheets instead of aluminum to reduce weight and make it lighter.
Fun fact, I actually have those cut and I will be showing them at the end of the slideshow.
We've been doing a bunch of cool stuff in programming this year. We write our code in Java using Android Studio and also various other editors. Then we upload the code onto the robot control hub, which is a little box, the brain of the robot, and it's Android based. We have a wireless, we have a phone which has a driver station app on it that wirelessly connects to the control hub in order to run op modes, which are like teleop or autonomous, run different programs on the robot, control the robot. So like we have controllers hooked up to the phone that can control the robot, which we'll talk about in a later slide. We use TensorFlow for machine learning, and we helped beta test a tool that the First Tech Challenge is creating that allows you to just upload images and it'll create a machine learning model that can recognize those images for you. And so that was really cool, really nice. We also have a diagnostic system for the robot where we can just put a file in a specific folder and put it in and then reference it in another file, and then just run it as part of a diagnostics op mode in order to just test out all of the different parts of the robot. And so that's been very useful as well. And then the picture behind the screenshots is of our setup for detecting ducks. And so you can see the control hub and a camera pointed at the duck, and the tablet is the driver station.
We also have autonomous actions that we need to perform. There is a 30-second autonomous period at the start of every match in which points can be scored by doing certain tasks. These points are often more than the period afterwards, which is the teleop period. That's in the next slide. No player input can be given to the robot during this period, so it observes the field with cameras and other sensors. And this year, we're creating a machine learning model using TensorFlow for recognition of our custom game element.
So during the teleop phase, we use a game controller connected to the control hub. Actually, we use two game controllers connected to the driver station, not the control hub, to allow two drivers, usually one for driving and one for delivery, intake, etc., to control the robot. So we spent a while deciding on what controls would do what, depending on previous members' experience with what worked and also new members' input with what they would like. And yeah.
Okay, so we've given a brief run through, and by brief I mean sizable length of what we've been up to. So what we're doing next is we're hoping to complete the intake and delivery systems and then attach and wire them into our drive base sometime in the coming month. So after we do that, we will practice, test, and modify our designs to have a working robot, and so improve them and sort of edit them to make them work as best they can. We are also going to be focusing more on software design and implementation of that on our bot, as well as focusing on design elements of our robot. So ideas have been stuff like having lights, sounds, and fun numbering. We had this idea of etching stuff into the into plexiglass, like having our team number on there. That would be pretty cool. And so February, assuming that we achieve all of our goals in January, we would be fine-tuning our driving, our software, and our robot, as well as fine-tuning our scoring strategy. So that is a big part of our game and our game plan, as well as it informs how we build our robot. So that is something that we need to fine-tune. We would hopefully be able to go to a scrimmage. There are many more Vermont teams now than there were 3 years ago. So potentially there will be a scrimmage this year, assuming COVID doesn't get bad again. We're also planning to do more outreach with local teams in Vermont and or New York. And we're gonna design and order our team shirts for our final competition in March.
So the Vermont State Championship is held on March 19th. For this season, it's March 19th, 2022. It's hosted by the University of Vermont at the Champlain Union High School. There are currently 19 teams registered from Vermont and 8 teams from neighboring states because this competition allows out-of-state teams to register since there are so few Vermont teams. There are currently 6 teams waitlisted. The roster gets finalized in February. In the past 2 competitions, the Manchester Machine Makers have won the Think Awards for second in 2020 and first place in just this last season. Charlotte, who was our president last year, won the Dean's List for Vermont in 2021. The Dean's List is a special award for students, and there are only 2 candidates from each state. So she was a Dean's List finalist last year. In 2022, with your help, we hope to continue to win awards and continue to be recognized while learning and having fun.
So we'd like to open this up to any questions. Does anyone want to know anything about the robot? What's happening this season? Any of that?
I'm gonna stop screen sharing if that's all right with you guys.
So I'll start. So everything looks great, and I congratulate all of you as the team members and the coaches and mentors that are supporting you in this. It sounds like you guys have done great things this season thus far. Say a little bit more about how you came up with all the great ideas that you've got thus far, and where I'm really going. I was really impressed with those. I forget who was describing it. Amos, it may have been you that was talking about trimming the intake wheels to be able to make them compliant wheels. What a great idea that is. How did you come up with that?
I think we just handed Zach a pair of scissors.
I think what actually ended up happening was we watched a lot of the videos of teams from the Rover Ruckus season, which is the challenge from the year before the team was founded. And we got a lot of ideas from the robots there. We were looking at a rake for the intake. A lot of our favorite designs had that sort of paddle design for taking in both spheres and cubes at the same time, because that was the field elements in that year as well. And then we also looked at some of Go Builda's videos for the robot in 3 days that were designed specifically for this challenge to get ideas.
So if I can follow that up, so is one of you kind of the person who tends to go out and find all the fantastic ideas that are out there in the world, or is that something that all of you guys do, or how does that work?
It's definitely pretty collaborative. You know, we have like a Slack and a Discord, or if anybody finds a good video or an interesting video of anything related to the robot, you can just post it on there, and then, you know, everyone will watch it. We can talk about it in the next meeting. So definitely everybody contributes.
Yeah. And when the challenge was first released, there was, I know for me at least, and for a lot of the rest of the team, there was like a solid week where it was just like a lot of those videos were being discussed in the meetings and outside of them, where we were talking about like, oh yeah, that Go Build a video, and what was it called, Isaac? The Rover Ruckus?
Yeah.
Names are hard. Bear with me. Like that one intake from there would be great with that drive base, etc. And sort of just brainstorming and finding little bits and pieces to build the ultimate Frankenbot.
Well, I probably got 30 more questions, but I'm going to stop and let other people ask theirs. So.
Hi there. My name is Julie Mackey, and I am a local science teacher. I have some former and current students on here, and I'm wondering, how do you recruit new members?
We just, so last year, we sent out emails to all of our schools. So Alex sent one out to his middle school, and Isaac and I go to the same school. So we sent one out to BBA, and we sort of got members from that pool. And then our coaches also sent out emails to people who they knew might have kids who were interested. And I know Mike, when he first started the team, put an ad in the paper. And we've used a couple of different methods throughout the years. And last year's was most effective. We got a bunch of new members this past year, which is wonderful.
I would say,
Awesome. Thank you.
as one of the coaches, I know GNAT is here. They helped us get the word out about the team with videos. We had an open house. We had an in-person open house last spring at the courthouse, which we hope to do again. We had hoped for today to be in person too, but just there's so much going on, but we hope to do that again. And so I think by word of mouth, people are hearing about the team, which is great.
And we also had like an orientation meeting earlier in the season for prospective new members so they could get an idea of what the team's about.
I'd say if anybody else has questions, if not, go for it, Mike.
You know, Mike, you were asking about the intake, and one of the things we did this year, there is an intake team. So there's, I think 3 or 4 of our team members have really been focusing on that. And I think, and they've been some of the newer members. And so they kind of came up with ideas and then collaborated with some of our senior members. So it's really been a team effort because we know in order for the robot to do anything, it's got to pick up this freight. So we've really been spending, I think, a lot of time on it this year. And it's been I think, really collaborative.
Yeah, we should mention that we have another coach also that couldn't be here today.
Yeah.
But Zach's dad is helping and has been mentoring the intake team pretty closely, which has been really great and helpful.
Yeah, also to build on that, it's been a really collaborative year, and we've sort of hit a groove where we figured out when meetings work and how long they should be, and not to mention that we're finally in person again, which has been wonderful because last year was fully remote, and that was fine up until we had to sort of merge everything together, and then that didn't really work, and our stuff worked apart, but it didn't work well together. And this year now we can talk way more like easily, and we're all in the same place and we're sharing the same ideas, and it's a lot better.
Yeah, expanding on that, it's kind of like a combination of what we were doing in our first and second years. In the first year, everyone was kind of working on the bot at the same time, whereas in the second year, pretty much everyone was independent on their own subassembly with like no one else. And this year we've split into subassemblies, but we also go between groups to help each other out and like talk about what's happening and make sure things fit together and don't conflict and all of that.
And we've been using SolidWorks a lot more. So I think that's been helpful before building, and having Randy Marsh from EPS, who I know has started his holiday break, but that's been great to, Isaac, I know, has been able to talk with him a little bit. He really expedited helping us get a piece cut because EPS is really busy right now. So I think it's all coming together.
Yeah, technology has been really key this year, not only with CAD, but we've been able to make meetings work a lot more conveniently with Discord and Zoom and various video conferencing technologies, which allows people whose schedules are a little too tight, for instance, right after school, maybe they don't have to travel to the meeting if they're not necessarily going to be involved in the physical building, but they can do software or outreach or any of these other things just from their own computers at home without having to incur that travel time.
So that all sounds great. So if I could also ask, this is kind of a broad question before I go down into my little technical details rat hole. Broadly speaking, since it sounds like the meeting days and times and number of times per week is working out well for the team. How many, can you say more there? How many times a week are you meeting? How much time are you meeting as a group? And then the follow on is, is there some amount of time that people outside of team time are also working privately or individually on their part of it?
So right now we have 2 meetings a week, one on Friday for 2 hours and one on Sunday for 2 hours. In this holiday break, we were also thinking of making workshop sessions in which people can come in and work. Last Monday, we had something like that. I think it was me, Charlotte, and Meg that were in there. And we were working on slides for this, and I was also working on putting delivery together. And then throughout these next couple of weeks in holiday break, we're going to have more of those workshop sessions.
In the month,
Yes.
I was gonna say the month of November when sports ended, there's like a 3-week window and there's no sports. We had 3 meetings a week. And that was really focused on, we had a hard deadline of getting that drive base going. And we felt like we couldn't take a break at Thanksgiving if that wasn't happening. So I think that really helped, those 3 meetings a week. And then we went back to 2 in December.
Same wavelength, Mom. Same wavelength. But yes, so we've also been having a mix of remote and in person, like Patty said, and we've been trying to meet as often as possible without sort of burning out. But we also are being aware that we can't really be stopping, because once we stop, we're going to have to get started again. And we've been trying to, at the very least, have 1 meeting a week, and at the most 3.
Yeah, and we have found that having shorter meetings more often helps us be more productive. So, I know the team has tried, before having like 4-hour meetings, and, you get to a certain point and then you lose a little bit of steam and you just start fooling around. And so what we decided as a team was that we'd rather have the shorter meetings and be able to really come, focus, and leave, and then pick it up again where we left off, rather than have that kind of downtime in the meetings that we weren't really making progress. So the team's been really good on figuring out what our limits are. And that has not been coming down from the coaches, that's been coming from our members, which has been really fantastic.
And as for working on the robot outside of meeting hours, we are sort of not self-determining when we're going to work, but it's less of a every night you have to do 1 hour, and it's more of a, oh, okay, we didn't finish everything we wanted to get done today. Can you come in and meet with us during whatever day you're free? Or, hey, we're trying to get some plexiglass cut. Can you make a file so that we can send it to the person who's going to get it cut for us? That sort of stuff. So it's maybe an hour or 2 every couple of days. I don't know how time consuming everyone else. Like, I know, like when we were designing the drive base, I was spending more time on SolidWorks. It was more 2 or 3 hours every few days. And that was a little more time consuming, but it depends on what time of year it is, what we're working on, what we're trying to get finished, if we have a deadline that's fast approaching, and yeah.
To that point, I think that the deadlines and goals have been helpful. Can't speak from experience in other years because I joined the team this season, but it's been nice to have those.
Yeah, and again, those deadlines were, the coaches advised on them, kind of looking at what had been done in the past, but this team members really set those in place and decided on them and agreed on them. And it was a really collaborative process, figuring out what can we do and what can't we do. And the members are really great. Thank you, Andrew McKeever, for coming. It was great.
Thank you.
Thank you. Real pleasure seeing you all again. I'm sorry, I got about 5 things I gotta do now.
That's
So,
okay.
anyway,
wanna
good luck.
We'll have you
Good
over
luck.
to our workshop and driving the robot at some point.
Yeah, well, that would be fun. I'd like to do that.
Great.
Yeah. And let us know if you have any questions that you're
Okay,
curious about.
You know, I meant to ask earlier, and I may have missed this part of the discussion. Are you having some sort of an event coming up in the near future or semi-near future, or that I should be aware of? Or you may have mentioned this already. I've been kind of back and forth, but so I apologize if you've already talked about it. But
No, I
is there
think we
something
hope to
coming up
have I think we hope to have another open house in the spring like we did last year. So
Okay.
we'll keep you posted and make sure you get an invitation.
All right, great. Yeah, please do. I'd love to check it out.
Great.
Anyway, sorry to have to dash early, but it's one of those days. Anyway, good luck to everybody and happy holidays and all of that.
Thank you. You too.
All right. See you all later.
See you later.
So I'll throw another question out there if I can. So for first year team members, you've got these real experienced 30-year, like they're old haggard 30-year team members. They're just old, long in the tooth, and they're grizzled and chewed up and frayed and battle worn and scarred and things like that. And for you newbies, I mean, you've got the fresh perspective and you can really come in and really show them how to do things now. And so I really wanted to invite you guys just to say a little bit more about what's it been like as a first year team member, and more importantly, how do you learn all this stuff? What's it been like at learning it?
Well, I joined the team this season, as I've already said before, but over the summer, like before the season started, we focused a lot on like doing training for people to do stuff like having to use SolidWorks and setting up like the license and stuff for that, and learning how to do like MATLAB and stuff and that stuff over the summer. So that was helpful before the season actually started to get that done, so we didn't have to get in the way of the time of making the robot.
I also joined this year, and at the beginning of the year I had like no idea what anything was, and I still don't have any idea how to use like SolidWorks or like program stuff or anything like that. But I know what a Sonic Hub is, and that's all that matters.
Yeah, I mean, I learned stuff like how to build a robot. That whole thing was, I mean, I had done it with a different program, but they used slightly different parts. So there's like different sizes on these and stuff, which made it a lot more complicated. So that was interesting.
So one of the things I'm also curious knowing about is sensors and all things electronic. And it looked like from the prototype, which I compliment you on having just a functioning, moving prototype, regardless, whether everything is exactly perfectly where you want it all to be. But it looked like in the prototype, you had the control hub standing up rather than laying flat, so that you'd have more space, I bet, to be able to intake the playing elements, which makes sense. But that kind of changes the orientation of some of the sensors that are inside of the control hub and things like that. So I just wanted to ask you, just kind of broadly and generally, say a little bit about what your thoughts are, either what your status is or what your plans are for kind of the sensors and the things that in autonomous that are going to make the bot know where it is, go to where it needs to be, do what it needs to do, and then move on to the next thing that it's supposed to do.
We haven't gotten to quite as much of the autonomous stuff yet, since we're trying to get a working prototype of the bot hardware wise, and we were planning on focusing that more towards the end of the season. But I think our current plan is using TensorFlow and that machine learning software to recognize our shipping element and the position. And then from there, using some of the IMU software we wrote last year, possibly transforming it a little bit to account for differences in orientation of the control hub and if it's rotated 90 degrees and where the components are and all that. But still using a little bit of that IMU software. I don't think we need to move that far, so possibly a little bit of encoders as well. And then also using TensorFlow for the image recognition.
Yeah, our next, our deadline for actually having designed our sensors and the way we're going to do things hasn't happened yet. So that's coming up, I think, early in January to have that plan in place and agreed upon, so that then things can be put into place on the robot and programmed for in the software. So that's getting ahead of us. We're really focusing on the teleop first, and then focusing on the autonomous second. We're kind of going with the strategy of minimal points first, like score something, and then worry about scoring more. So that's why we focused on the drive base first, right? We have just a drive base. We can score points with just a drive base. We can't score points with just a camera system. But we can score points with a drive base. And as long as it can move, we can do something, even in autonomous, using encoders, and that's it. But obviously we want to do more than that. And Isaac laid out a pretty good summary of, I think, where we're going to end up.
I also feel like this year having the competition be in March has really given us a little breathing room to get this together. Because before, when it was in February, seemed so like under a lot of guns over the holiday season, especially, that we have a little wiggle room.
I'll throw out another question. How's the math been? Has there been a lot of math, a little math, no math, nothing but math? Anywhere in that.
We need you to come in and do a little math consult, Mike.
No, it's okay. I'm sure there are people better than me at that, but I just wanted to see what you guys are. How's the math? Is it muddy? Is it thick? Is it quicksand? Is it just what do you got? How's it coming on math stuff?
I can speak for the delivery at least before I pass this on to the intake, but on the delivery, the math hasn't been all that bad. There have been a little bit of geometry calculations like tangent and cosine and all of that. Because the slides are at an angle, it ended up being 74.756 degrees. And then you kind of have to translate all of your measurements from that because everything's tilted. And then there were some torque calculations. SolidWorks ended up helping out a lot with that because you can get a mass from the model and also distances from measuring tools. So I've really made a lot more use of the evaluating tools in SolidWorks this year, which Randy had showed us how to use. And aside from that, the math hasn't been all that bad. We've used SolidWorks to help out a little bit, and then it's just geometry stuff from there. Intake, what has your experience been with the math?
It's also not that bad. It's actually almost like a little bit less math than I expected, which is like fine. But like the main, again, like geometry, like triangles. That's basically as far as we've gotten, like with having to use math.
Yeah,
It's
we haven't
not
gotten
nearly
to
as
the
bad
motor
as-
stuff yet, so we don't have to figure out the rotations per minute and whatnot.
Right.
Okay.
But it's not nearly as bad as last year with the projectile motion and drag and all of that stuff. It's been a lot simpler.
Yeah, we're not
You're
allowed
right.
to
Yeah.
launch things this year.
Unfortunately, it's devastating. But yeah, a lot of the math so far for the drive base as well has been just making sure stuff will fit. So a lot of geometry addition, just communication with others to see how big their part is and making sure it's going to fit within the constraints of yours. Yeah.
Yeah, one thing we have done, the team did this a couple weeks ago, was to put the CAD for all the assemblies together on the CAD for the drive base to see how it would fit before we actually started putting it together. So that was a big achievement, I think, for the team.
Also, Amos was talking about his triangles and such, and we finally got those printed today, or not
Hey.
printed, laser cut. One sec, let me just turn off my background and you'll get a better image there. So we got those cut out. These are acrylic, so plexiglass-esque. They're covered in protective paper right now. And I'm assuming this is the ramp for the intake, which is just a rectangle, not a triangle. I know my shapes. And this is Isaac's piece for the delivery system. There's still 2 more that need to get cut.
That's the base of the chute.
So we've been hard at work.
Yeah, we've been really lucky 3D printing the pieces for the slides with Amy Wright at BBA, and then Paul Molinelli met Charlotte this morning to do the plexiglass with the laser. They have a special laser cutter, I don't know.
Laser cutter.
Yeah. So we've been really lucky. They've been super helpful and supportive. And then EPS with the aluminum for your other piece, Isaac.
Yeah, that was really helpful. Otherwise, we probably wouldn't have been able to put the linear slides at an angle. And if they weren't at an angle, then it would be too tall and we would not qualify for the competition because we would not meet the requirements.
Yeah, the biggest, this year the robot's narrower and just keeping within that 18 inches of the height. I think that's, I keep sort of hearing like, is that too long? Is that too tall?
Yeah, you've always got to keep the size requirements in
Yeah.
consideration.
Yeah, because the robot is skinnier and the attachments are all longer. We're in danger of overrunning the length and also the height, even though we're well within the width. So Isaac's design of the delivery system includes the chute folding up to make sure that we stay within the 18 inches at start.
That's one thing that we have this year that we haven't had in previous years is a folding robot that unfolds once you
Got a
start.
transformer.
Mhm.
So have you guys done things to kind of figure out feeds and speeds? You know, this is going to spin at this speed and it's going to put things through at this velocity, or the bot's going to move at that speed, and you know, kind of things along those lines. You will, don't worry about it. I guess I was just curious if you had already done it. So
No,
No, not yet. That is it's on the list, but we haven't gotten to it.
one of the benefits of having people being able to build and prototype in person this year means that a lot of experimentation can take place, whereas it was much harder to do that last year.
what's your biggest bottleneck at the moment, or your biggest constraint that you're most, what it could be organizational, financial, could be time, could be you need unobtainium to be invented. What's the biggest constraint that you're constrained by at the moment?
I would
That's
say
gonna be
it's people's
different depending on
schedules.
who you ask. Oh, that's true.
What did you say?
Which is really an extension of time.
People's
Yeah.
schedules is what I
Oh,
said,
yeah.
Meg. Yeah. It's just hard to coordinate when you've got, a team that is this awesome and big. We need to coordinate more, and everybody's got different schedules and different sports and different requirements. And it's really hard to make sure that we meet enough times in a week and have enough time together. And yet, everybody can still be there. So that's been,
Yeah.
I think, the most challenging part.
Yeah, I've always for the last 3 years, I've always been a huge sort of promoter of team communication. That's just everyone needs to check their Slack, check their email, whatever. Just make sure that you know when the next meeting is. And that's always something that we're going to struggle with, I think, especially now that we have a big team. Yay! But it's like we had 5 members, now we've got 9. It's fantastic, and I'm so excited. But we have 9 members, and that means 9 conflicting schedules and 9 people who potentially like are having tech difficulties and can't get on the Zoom meeting, or 9 people who potentially don't know there's a meeting today because they didn't check their Slack or something like that. And it's just like, okay, great.
Do you also want us to expand on like the challenges with the individual sub-assemblies or just as a team in general?
Yeah, sub-assemblies. Let's dive in.
All right. The delivery challenge at the moment is the pulley system, because there's going to need to be 4 different cables all attached to pulleys, one on the left slide extending that up, one on the left slide bringing that back down, and the same for the right slide. And that's all going to be hooked up to one motor. Since we've got such a skinny bot and it has to go around the intake, there's going to be a lot of weird routing and size constraints and figuring out what pathways to take and stuff on that. So I think that's currently the largest challenge on the delivery side. What about you guys, intake?
I feel like one of our problems is just lack of experience.
But that's what experiments are for, right?
Like,
Yep.
we're all learning.
Like cutting up the wheels.
Yeah.
Yeah.
Yeah, and we've been fortunate in the donations that we've gotten. You know, we've applied for a bunch of them, and we've reached out to a bunch of organizations, and they've been generous, and that puts us in a really good position to support the experimentation, to gain the experience that the team needs, and hopefully lead to success at the championship.
Yeah. An issue that sort of has been universal amongst the sub-assemblies is the disorganization of our parts, because our Actibotics parts are mixed in with our GoBuilda parts, and Actibotics and GoBuilda have different sizes and different, like, they're metric and imperial. They do not mix. And so there's only a few Actibotics parts in our GoBuilda. We've been pretty good about, if we figure out that we're using one, we just take it out of the system, and we have a little box that's marked GoBuilda or marked Actibotics do not use. But it's annoying because, like, you build this fun little prototype that you feel might actually work, and then you try and put an axle in and it doesn't. And that's just really irritating.
We're trying to organize, and Charlotte just spent a big chunk of time last week organizing tools and things. But one of the flip side is that we have a lot of stuff for them to prototype with. It's not like starting from scratch with nothing. Like, there's stuff they can actually touch and feel and put together, and before we have to start ordering things, which is really nice. It's a luxury, actually.
And it's great. I remember our first year, we just had the giant tub, and that was it. Yeah.
So is the drive base kind of signed off as final, or is it still pending evolution?
It's pending evolution. So it's right now, it works about 90% of the time. There are issues, as always, with the vibration of the drive base as it moves across the field, messing around with how tight the screws are, or whether or not our gears are going to move or not. And it's irritating, to say the least. And so it works until it doesn't. And so we're trying to fix that. But the sort of general shape of it probably won't be changing as much as the sort of functionality of it and where stuff will be going as we add things to it, because we're thinking of adding, like, walls to the side, which will probably mount the control hub to, or we're going to add the intake, which will mess around with where other stuff is going to go. it's all up for evolution. There's another word, but I can't remember it right now. But so yeah, as stuff is added, it will be changed.
Right, and the wiring certainly isn't final. When we were driving it around, we found that it would occasionally, bump against the wall and pull the wires out of itself, and that was obviously something that needs to be fixed. But until we get the rest of the bot put together, or go in other directions, we don't want to finalize the wiring because it's just going to have to move again.
Is there a sub team on the drive base, or is it? Have they been kind of, that sub team is dispersed and they're on other sub teams now?
Yeah, that's been Charlotte and Piper for the most part, along with anybody else who happens to want to tighten a screw.
Yeah. Didn't Dakota work on it a little bit, I want to say?
Yeah, Dakota, you worked on that, but too, didn't you?
I mean, I tightened a couple of screws.
There you go. But yeah, I think you're all kind of doing other stuff mostly right now because the drive base is kind of in a state where it's just pending. And it's waiting for these other things to finish. So Piper's been instrumental in the newsletter and all the outreach. And Charlotte's been very busy organizing tools and just like overseeing lots of building of other things, which has been fantastic. We've been helping out Isaac, I think, a lot on the delivery and pitching in as needed.
Seems to be that we're like winding down. Is there any other like last questions and stuff?
All right.
Thanks for coming.
I don't have
everybody.
questions. I just wanted to say thank you. I find this really interesting. And the one time I stopped by the shop and got to see some of what you were doing was great. I'm looking forward to the next open house and hope that it can be in person and can sort of see it all work together after hearing you talk about the process.
Definitely.
So thank you.
Yeah, well, thank you all very much for coming.
Yeah.
Thank you for hosting this, and congratulations on your progress thus far.
Great, Mike, it's great to see you. And thank you everybody for coming.
Thank you,
Thank you.
everyone.
Yep.
Yeah.
Thank you for
Thanks very
coming.
much.
Thank
See
you so much
again.
for
Happy
coming,
holidays
guys.
and a happy new year.
You too.
Yeah.
Happy holidays
Happy
to you.
holidays.
Thank you.
Happy holidays.